Hi, today I'd like to talk about how we use the Pythagorean Theorem. Now, the first thing I want to really stress is the Pythagorean Theorem only works if we are using a right triangle. Okay? Has to always be a right triangle for the Pythagorean Theorem to work. Now remember, if you look at a triangle and it looks square, you don't know for sure if it's square unless you see the notation for a right triangle, which we see right here. The Pythagorean theorem states, in a right triangle, the square of the length of the longest side is equal to the sum of the squares of the lengths of the legs. Now, as we look at this triangle over here, the legs are our side A over here and our side B over here. Those are the legs. They form the 90-degree angle that makes our right triangle. Now, the side that connects the two, which is right here, side C, is called the hypotenuse. Now, what Pythagorean theorem is basically saying is that a squared plus b squared equals c squared, or the legs squared added together equals c squared. We're going to show you a couple examples of how Pythagorean theorem works. In this first example, they want us to find the length of the hypotenuse of the right triangle. Now we need to quickly identify the legs. Again, the legs are what form the actual 90-degree angle in a right triangle. So they're over here, right here. And we're going to label this side A and side B. Those are our two legs. So X is going to be our side C. And as we learned previously, the Pythagorean theorem is a squared plus b squared equals c squared. Now we're going to go ahead and substitute our numbers for our legs in for a and b, and then x in for c. So we get 8 squared plus 6 squared equals x squared. Now we just go ahead and solve for x. 8 squared is 64 plus 6 squared is 36. And again, when you're squaring any number, it's just that number times by itself. Equals x squared. Now 64 plus 36 is 100. Equals x squared. Now to get rid of the squared sign, as we solve for x, because we really want x by itself to get the length, we have to use the inverse operation. So the inverse operation of squaring something is using the square root or radical. So I'm going to go ahead and take the radical or square root of both sides. On this side, it equals x. We got rid of the 2 by using the radical. Okay. On this side, the square root of 100 is 10. So the length of our hypotenuse, which is what we're trying to find, is 10. On the next example, this time, instead of trying to find the hypotenuse, we're actually looking for a leg. Actually, we were supposed to identify whether this is a leg or the hypotenuse. Now, if we look again, the legs always form a right triangle, or the 90-degree angle. So this is the leg right here. X is a leg, and also 3 is a leg. So I'm going to label these again, A, B, and C. And so now we know that we can use the Pythagorean theorem because it is a right triangle. So we get a squared plus b squared equals c squared. And all we do again is substitute our numbers or variables in, and solve for the variable. So we get x squared, that's our a value, plus our b value is 3, so 3 squared equals, our c value is 5, so 5 squared. Now if we go ahead and solve for x, we get x squared plus 9, 3 times 3 is 9, equals 5 squared, which is 25. Now to keep solving, I'm going to subtract 9 from both sides, and I get x squared equals 16. And again, to get rid of the square root, to get rid of the squared, we have to use the square root. So I go ahead and take the square root of both sides. I get x equals 4. And that would give us the length of that side. X is 4. Here are some of the common Pythagorean triples. These are the ones you'll see a lot. Some people memorize these. I don't expect you guys to memorize these, but I would copy this chart and keep this chart around. The most common you will ever see is this 3, 4, 5. And the reason these are called the common triples are these are the ones that you get easy numbers to work with. So if a leg is 3 and a leg is 4, then your hypotenuse is going to be 5 or a whole number. You won't have to simplify any radicals or simplify any expressions. These are the easy ones. So if we want to find the hypotenuse here, we could use the Pythagorean theorem. It is a right angle, so a Pythagorean theorem will apply. Or if you can find it on a list like this, I can look up at my chart and see that 10, 20, and 24, if the legs are 10 and 24, then the hypotenuse is 26. So I can just look at this chart and say x equals 26. Alright, and here's another way you might see a problem where you need to use the Pythagorean theorem. This one states, find the area of an isosceles triangle with side lengths 10 meters, 13 meters, and 13 meters. So our triangle is over here. It wants us to find the area. You know, oftentimes I will highlight what it's actually asking for so we don't make a mistake later. Okay. So the formula for the area of a triangle, area is base times height divided by 2, or 1/2 of base times height. Okay. I can see my base is going to be down here. This is going to be the base. Okay, so it's actually going to be 10 meters. And here's the height up here, but we don't know the height. So to be able to find the height, I'm going to have to use one of these two triangles, and I'm going to go ahead and choose this triangle. And I'm going to have to use the Pythagorean theorem to find that leg or that side. Again, the Pythagorean theorem is a squared plus b squared equals c squared. I'm going to go ahead and label my sides. This will be my a, h will be my b, and 13 will be my c. That is the hypotenuse. So I go ahead and plug the numbers in, and I get 5 squared plus h squared equals c squared, which is 13 squared. Now I know that 5 squared is 25 plus h squared, and 13 squared is 169. Now if you don't know what they are squared, just grab a calculator and use a calculator to find out what they are. As I continue to solve, I'm going to start by minusing 25, or subtracting 25 from both sides. That leaves me h squared equals 144. Now when I take the square root of both sides, because I want to get rid of this squared sign, that leaves me with an h, and the square root of 144 is 12. Now, are we done at this point? We are not. We need to find the area. That's what it's asking for. Okay? So we need to take what we found and plug it back into our area formula. So area equals base, which we already found to be 10 meters, times height, which we just found out was 12 meters, and we divide it out by 2. At this point, you can either plug it in your calculator or solve it however you see fit, but it's going to equal 60 meters squared, and that will be the area. Okay, now let's kind of sum things up. If a triangle is a right triangle, let me see. So if a triangle is a right triangle, then we can use Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, but the converse of that states that if we know that a squared plus b squared equals c squared, then the triangle is a right triangle. And we're going to talk more about that in the next unit.